So here's our UML for the coordinate class. First line of a UML diagram is a class name. The second box in a UML diagram can go by a lot of names, often called properties. These are the properties, these are the data that it holds. Member variables is another excellent name for that. And then lastly are the methods that act upon the data. So a class is typically data and the method that acts upon the data. One of the design, my brain just hitched. There's some rules of thumb you should use when designing classes. One is that you should make your data protected or private, and you should make your members public. That's called data encapsulation. It means that you can validate the data as it is being set, and that the programmer can only access the data through the specific interface that you define. And that's generally a good thing. You know, if you need to put some security in to make sure that the user has the rights to change X, you can do that. You can make sure that they're not putting in bogus values. So data private, members public, that's one or two of the design concepts that you should follow when creating classes. Another one is to add a custom constructor if it makes sense, if it will make using a class easier. In this case, it will make using a class easier because I can make the object and I can set its X, Y, and Z values with a single call, rather than having to make the object and then issue set X, set Y, set Z. Now, there are times when that doesn't really make sense. What if you're dealing with an employee class that has 30 or 40 different attributes? You know, you're not going to be able to create one constructor that lets them set 30 or 40 different attributes all within one get-go. Okay, so let's add to our class guidelines. Data public, nope. Data private or protected. We'll talk about the difference of that when we start talking about inheritance. Members public. Add a parameterized custom constructor if it makes sense to set the member variables, the instance variables. We'll talk again about what an instance variable is. All right. Third would be to add a toString to turn the class into useful data for debugging. And then add a .equals method to compare two objects if that makes sense. If you're dealing with an employee class, you probably don't need to compare two employees to see if they're equal. But points, geometric points, yeah, you might want to know if the 2 points have the same X, Y, and Z. Okay, so those are 4 class guidelines. We may add some more to this. Alrighty, pop open NetBeans. Yes, sir?
Could you put that out?
Mm-hmm. If it's on. Oh, I see a light. Yippee. All right. Now, if this was a Java 1 class, I'd reinforce the idea that this is not how you define them in Java. We have to turn this into Java syntax, and that's because this is a universal modeling language. Unified, excuse me, not universal. And it's for any programming language that supports these concepts. So I'm going to make a new class, new project. I don't care about the name of it, but I do care about the name of the class I'm going to make next. I'm going to add a class to my project called Chord. So up here inside of Java Application 10, I'm going to right-click, New, Java class. Here's the name of it, Chord. Alrighty, that matches that. You know, I guess if we wanted some absolute parity between using the plus signs to mean public and stuff like that, but you know, generally you can assume that your classes are public. unless otherwise identified. The only time you need to make classes private if you're trying to stick more of them into one file. You know, if you keep your classes separate, one per file, then they're public. Alrighty, so we need 3 variables, but they need to be private. In C, we just do this. We would type private, and then we would define all of our variables. This is not C, so we're going to do private int x. I could do it in 3 lines, or I could just do x, y, and z. I'm going to cheat and do it like that. I mean, it meets the criteria. It has 3 variables, 3 member variables, 3 instance variables. An instance variable is one that is not defined with the static keyword. Okay, now we need our methods. Let's add our constructor. It always makes sense pretty much to make your constructor public, and I had put plus signs here, so everything's going to be public. So it has the same name. Oh, I need to add that down here. What is a constructor? A method that has the same name as the class, no return type, and is invoked by the new keyword as the object is instantiated, created, whatever your favorite euphemism is. Okay. So we're going to have a constructor, and it needs 3 variables. It needs an int x and an int y and an int z. Int x, int y, int z. So this dot x is equal to x, this dot y is equal to y, this dot z is equal to z. Now what's with this reference business? If I left that off, it wouldn't work. The reason why is because with this being called x, we need something that will differentiate between that one and the member of the class. If I called these something else other than x, y, and z, I wouldn't need this keyword. If I call this A, B, and C, which doesn't make sense since we're talking about, you know, points, then I could do, don't make this change. X is equal to A, Y is equal to B, Z is equal to C. That would work just fine. But I wanted to call these the same names as they are defined in the class, because these are very useful names, the X coordinate, the Y coordinate, and the Z coordinate. And in order for it to distinguish whether I mean the parameter or the class member, I'm going to reference the class members, the instance members, with this keyword. All right, I've tackled that one. Now I need to add the 3 getters and the setters. This is kind of tedious. We can do it. I'm just going to add one of them, and then I'm going to cheat and let NetBeans add the rest. So I'm going to do set x. Well, it's public because it's got a plus sign in front of it. Public set x. And it takes an x as a parameter. This dot x is equal to x. Again, the same thing. Oh, public void. My mistake. Alrighty. Now that's a lot of typing. I mean, not really. You know, it'd only take 3 minutes to add the other ones. But here's how you cheat. You refactor. Highlight the 3 variables that you want to create getters and setters for. If you put them all on 1 line, great. If they're on 3 lines, highlight all 3 lines. Then do refactor. Encapsulate fields. Encapsulate means provide getters and setters for them. And then it pops up this little dialog. It notices that we've already got set x, so we're not going to have to create that. That's why it's got a red dot next to it. But it's going to add a get x, a get y, and a get z, and it's going to add a set y and a set z. Then I click refactor, and it goes for it. So if I scroll down now, I'll see the code that it generated. It added some comments to it, you know, so that you could use Java2 on it. We need to talk about Java2 at a certain point. I'm going to take all the comments out because they just fluffed it up. Made it harder for you to see what's going on. But you get the idea. All of a sudden, I have a set and a getter and a setter, a mutator and an accessor for every one of the variables I had highlighted.
Can you show me how to do that thing in that game again?
Absolutely. I'm going to add some more variables and then I'm going to delete them. But like if I had a string called name and a string called address, here's how I add the getters and setters for name and address. What I do is I highlight those two lines, however you like to highlight things. Just click and drag. Then do refactor, encapsulate. Who was asking? Someone was asking. So they're all selected. That one we'd already added, so it's got a red mark next to it. That's fine. The rest of them are good, and then we're going to click. Yep. And then if you scroll down, you'll see the getters and the setters.
It's just unlicensed devices.
That makes sense. You need the lights lower back here.
It's only going to make it harder.
Okay.
Can't do it practice.
Yeah. Alrighty. Now we have a class we can use. I'm going to go back over to my main method over here that got created. And I'm going to demonstrate that I can use the constructor. I'm going to cover this up because I'm not using the UML anymore. Alrighty, so if I want to make a new coordinate C1 is equal to new coordinate. Is that going to work? No, it's actually not going to work. I'm going to comment that out for now. But then I'm going to type another one. Chord C2 is equal to new chord. And I get to specify the x, y, and the z values. I want this one just to be 0, 0, 0. And that did work. Now, why didn't this work? This is the same syntax that we've always used before to create an object, and all of a sudden it's failing on us.
The constructor defined the x, y, and the z, so if you don't have that, it doesn't know how to deal with it.
Exactly. If you provide your own custom constructor, as we did here, it stops providing a default constructor. If you still want it to work the way it used to do before you did that, you can add a simple default constructor that looks like this. Public chord, it doesn't need to accept any parameters, it doesn't need to do anything, but there, now I have regained the ability to create them with that prior syntax. That's worth remembering because sometimes, you've already created a huge body of code that relies on that class. And then you think, oh, well, I'm going to add a constructor to this class. And you already have 6,000 references to that class. Then if you add the constructor to it, suddenly those 6,000 references may be broken. It can't make the object anymore until you go back and you add the default constructor. I'm going to add a comment here. Default constructor. This is necessary if I want to use the usual syntax. That sounds like a Quentin Tarantino movie. The usual syntax to create a la chord C is equal to new chord. I had to add this because once I added the parameterized, you don't have to type all this, but it may help you burn it in. Constructor, the default one, was no longer automatically provided by Java. That's worth tacking onto our notes over here. Parameterized constructor, default constructor, Yes, yes. All the members get initialized to 0 or the equivalent. Empty strings. No, not even empty strings. Nulls. Why didn't it let me copy that? All right. This is not the default constructor. I pasted it onto there, but it's not. This is the parameterized parentheses custom constructor. And if you want to make your default constructor do something more unusual than just nothing, which is what we did, you could do so. Like you could make it initialize all the values to -1 or something, but you could have done that just as easily by, doing int x is equal to -1, int y is equal to -1 here. Okay, so up here, I've created a coordinate. Now that I've added my default constructor back, I can do this. It would be really nice if I could do this as well. If C1 is equal to C2, system.out.println, they are the same. They look like they're going to be the same because x is 0, y is 0, and z is 0 for C1. That's going to be the same for C2. But when I run it, they're not the same. It didn't print anything, which means that they're not the same. I didn't add an else clause to print, but I could have. Else print line, they're different. So there we go. It says they're different, even though if we printed out the x, y, and the z value of each one, we would find out that they're the same. So, with the idea that we're going to add a toString method and a dot equals method, I'm going to add a little bit more out. Above our line, or even below it, I'll just add it on below, it doesn't matter. System.out.println C1 is plus C1. Then system.out.println C2 is plus C2. Now, if we had a good toString method, this would provide useful information. As is, it's just going to print the address in memory of those two objects. Sorry. There. Where'd my output window go? There it is. So this actually gives us a clue as to why it said they are different. All it did is check to see if they were at the same memory address. When you use double equal on an object, and this is true of strings as well as anything else, all it does is check memory addresses. So what we really need to use is a dot equals method, just like you do with strings. So I have to come back up here to this code, and instead of saying, because this isn't C++, I can't override the equal equal operator, I have to do this. If C1 dot equals C2, now the code's still not going to work, but we're getting closer to being able to make it work. It still says they are different because dot equals is still doing the same thing. We have not added our own dot equals method, so one is being provided for us by Java. And although we haven't talked about inheritance yet, the reason why there's a dot equals method and a toString method that we're getting to use is because the object class, the root class for all Java objects, all Java classes, has a dot equals method and a toString method. So when you call dot equals on any class that you create, it just compares the addresses. Does C1 have the same memory address as C2? No. And if you call toString, which we are actually doing here, because if you send C1 or C2 and you try to append it, concatenate it to text, it calls the toString method, then all you get is the name of the object and its address, which might be useful, but we could make it a lot more useful. Why don't we add a method that will make it so that when we print it out, it actually prints the x, y, and the z coordinate. And then we're going to add another method to check the x and the y and the z values. And if they are the same, then it will print that they are the same. So we need to do two things. I'm going to go back to my UML and add these on. We need a equals method that takes another coordinate and it returns a Boolean value, a true or false. And we're going to need a toString method, which takes no parameters and returns a string. So I'm going to do something really stupid just to indicate what toString does. I'm going to go back to my coordinate. I'm going to add toString down to the bottom, but it doesn't really matter. Public string toString. Return coordinate, dude. Now that's dumb, but now that I've done that, when I run my code, it's going to say coordinate, dude. Coordinate, dude. You're getting the idea. This can be used to provide some description about the state of the object. Now that's a really lame description. We're going to provide a better one. String.format %d space %d space %d comma x, y, and z. So when I run it, instead of just saying C1 is, and then giving a class name followed by a memory address, it's giving me the x and the y and the z coordinates. That's actually useful information. It makes sense now to try to print that object. Adding a toString method to every class you make is not a bad idea if the object has any state information whatsoever. And this does have state information. It has 3 instance variables. Okay, so add toString if you've been following along and run it and make sure that it gives you some output like that. And then we're going to add a dot equals method, which we will use to compare. Public Boolean equals. Now we're comparing 2 coordinates, so we have to pass in a coordinate called other. Well, it doesn't matter what we call it. We can call it x, we can call it y, we can call it Fred. But you'll see why I like the word other. If this dot x not equals other dot x, return false. If this dot y not equals the others dot y, return false. If this dot z not equal other dot z, return false. And if none of those work, then they match. So we're going to return true. I suppose we could try to also keep the ability that it would just check the addresses first, and if the address of both objects are the same, then return true, but nah. Does it give me a warning here?
So wouldn't you want that to be a separate function? Because then they would be the same exact core class rather than just being equivalent.
Right. We have decided, or I have, as I've created this, that I want to be able to compare 2 strings to see not only if they are the same exact object, but if they have the same content. Just like if you have 2 strings. If you're reading a name off the internet and you're comparing it to a name that somebody typed in, those will not be the same exact object, but they will have the same contents. And if they are the same exact object, they will still return true, because this and other will point to the same address. Why is this telling me that this is redundant? Oh, really? Okay. All right, now it should work. If I run it, it's going to tell me that they are the same. That's the first time we've seen that message. So what happens is when we compare the two objects with the dot equals method, it compares this object, the one we're currently in, with the x, y, and z values of the other object that is being passed in as an argument. If any of these values differ, we return false, else we return true. I want to modify this to indicate that we have the dot equals. Okay, I kind of did this wrong because in UML you're supposed to list the data item first, followed by the data type, so it should be other : chord. There we go. All right, so now we have a UML and we have code that matches it. I'm going to copy this code into the notes page. Then I'll wander around and make sure everybody's got it working with no typos. Clean the rest of that up later. Well, we'll take that one. Okay. Back to this. These were the last things we added. If that's what you need to see, cool. If you need me to bring back main, that's also cool. Got it all working?
Oh, yeah.
Cool. Got yours rocking? Excellent. Cool deal.
Yeah, mine's working.
Cool deal. Excellent. Get yours working. Oh, you have to add a return. So after that last if statement, insert the one, yeah, put return true. Sure. Go back to Java application 7. Let's see what the errors are. Oh, it's C1 dot equals. Okay, so it's the same. Cool. Yes, sir. All right, gang, that's really all we need to know about UML, except the idea of what UML looks like when you're dealing with inheritance. And we're not talking about inheritance yet, so that's about enough. Chapter 6.ppt. If I could find the old one of these that we had opened, it would be dangerous. line. I'm not remembering where we left off. Again, it's doing that sneaky little thing where it's not giving me the thumbnails down the side. So we'll just rough it. Okay, so UML diagram, class name, your attributes slash variables, middle, operations slash methods. Notice that even they are giving multiple names of these things. And it's just because different computer scientists, when they were coming up with the idea of object-oriented programming, we're calling these different things. In the C# language, these are often known as fields. They've just got to give them another name. In Python, everything is a function, so you don't call them methods, you call them functions. For, same kind of idea. Okay, I know that we had talked about the mouse driver and Gus and all that. We may have almost gotten all the way through here. Here they're just showing, not that you can really see it, the minus signs for the private or the protected members, and the plus signs for the public. At this point, the way we are using these now, private and protected are synonymous. When we start talking about inheritance, we'll find out that private locks the data down more than protected. But in terms of just a client class and then another class, they mean the same thing. So a local variable. A local variable is one that's declared inside the method. The local variable is called local because it can be used only inside that method. If we go over here, this here is a local variable. So is that one. Those references are lost as soon as main exits, And then if nothing points to that object that was created on the heap by that statement, then the garbage collector comes and deletes that. So another example of local variables. We might want to do something called, I can't even think of anything. Public static dummy. Int x, int y. X is equal to 0, y is equal to 1. And now we're going to have an if statement. If x is equal to 0, you really don't have to type this in because this is just about almost garbage to illustrate a point. But if you want to, that's totally cool. If x is equal to 0, we're going to declare another variable named x. Or another variable named y. And we're going to set that equal to 100. Is that going to give us an error? Some languages it will, some languages it won't. This one it will. If you are a C programmer, then you will get an error here. If you will not get an error here, it's happy to do this. What we are trying to do is to declare another variable in the same place with the same name. And the reason this works in C++ and the other C languages is because it has defined this as being more local than that one. It hides that one so that by the time you get out of this pair of braces, this variable disappears, but this one still stands. And when we set something equal to 100, we set this one equal to 100, and this one maintained its value of 1. Okay, so int z is equal to 100. If I try to print out z, I'm not going to be able to do that. System.out.println z. The scope of the variable, the lifetime of the variable, is within the braces in which it is defined. Z is not defined here. It's defined within a pair of braces that this code is not within. So, looking at the scope, we see that variable there, but we don't see it there. The only things that are in scope at this point are any variables that were defined as part of the class up here. There are none. And then the local variables. And any parameters that were passed in, again, which are none. So these are all local variables. Local variables get created and they disappear as you enter and exit code blocks. X gets created, Y gets created, Z gets created, but as soon as we leave that code block, that memory is released. You know, Z could be an array of 1,000,000 elements, but as soon as it leaves the code block, the garbage collector is supposed to notice that and remove that from memory. So I can't print out Z here, but I can print out X and Y. So along with local variables, you have instance variables and class variables. Let me show you examples of instance variables and class variables. An instance variable is one that differs element by element. This is wrong. I didn't make it void. Okay. Our X and our Y and our Z coordinates here are instance variables because they may differ for every object you create. You know, you create two different coordinates. Maybe one of them is going to have 1, 2, 3 as those values. Maybe the next one's going to have 0, 0, 0. You know, they can differ on an instance by instance basis. If I go back to my application that created the two coordinates, if I change my second one to be a 1 and a 2 and a 3, it's got different values than the first one did. 0, 1, and 2, you know, or 0, 0, 0. Instance methods are the same way. They are methods that are not defined with a static keyword. So over here in coordinates, these are instance variables because they are not defined with a static keyword. These are instance methods because they are not defined with a static keyword. If we add the static keyword, it becomes a class variable or a class method. And it is the same for all objects of the class. And as a matter of fact, you don't even have to have an instance of the class in order to use them. So I'm going to make a static variable called number, which indicates the number of coordinates that have been created. We're going to initialize it to 0, not strictly necessary. But each time we call a constructor, we're going to add one to that, number plus plus. So I had two constructors here. I'm adding number plus plus to both of them. And to make things totally easy, I'm going to make this a public for now. Just so I don't have to add a getter for it. I'm being lazy. I shouldn't do that. I'm going to make it private, and I'm going to add a get number. Public int get number, and all it does is it returns number. But it has to be static. At least it has to be static in order to work the way that I am intending it to work. Okay, so each time we call one of these constructors, it's going to increase that static variable. There's only one number, no matter how many thousand coordinates we create. There's only one variable called number. It does not change on an instance by instance basis. Alright, so if I come back over here and I start printing out the number before and after I create them, system.out.println coordinate.getNumber. I'm going to do that before I create any of them, I'm going to do that after I create one of them, and I'm going to do that after I create the other one. Notice that I did not precede this with the name of an instance. I didn't say c1.getNumber or c2.getNumber. I preceded it with the name of the class. And that's because this is a class method. It was declared with the static keyword. You know what? I just wish that we would start calling it a static method rather than a class method. But it's a method that applies to the class as a whole, not to an instance of the class. You know, equals applies to an instance of the class. get X and set Y and get Z all apply to instances of the class. They were not declared as static. However, get number was declared as static. So we don't use it on an instance of it. We do not say c1.getNumber. Some languages will let you do that, but Java either generates a warning or a flat-out error if you try it. Let's see. I'm going to try that. Don't make this change. c2.getNumber. Okay. It just generates a warning. It's legal, but it kind of hides the fact that what we're dealing with is a class method there. Okay, so I run this. After the first object was created, we have 1. After the second object was created, we have 2. If we do this even after these objects are completely destroyed, that information still stands. I will demonstrate. I'm going to come down here and I'm going to make it like 10 more objects. For x is equal to 0, x is less than 10, x plus plus, coordinate c is equal to new coordinate 1, 2, 3. Oh, int space x is equal to 0. And now if I print out the number, system.out.println cord.getNumber, it will be 10 higher than it was before. Now these objects will be gone by the time we get here, depending on how fast the garbage collector cleans them up, because they won't have any references to them. But that counter will still exist, because that counter exists outside of those instances of the object. It applies to the class as a whole. So I'm going to run it, and after those 10 objects are created and destroyed, the counter is 12. Because each time we called the constructor, it incremented that variable, and nothing ever decremented them. We're not decrementing them as they are destroyed. C++ has a concept of a destructor as well as a constructor, which is a method that gets called when that object is freed, when it's released. I'm not even sure that Java has a destructor. Destructor. Is there a destructor for Java? The almighty Stack Overflow will tell us. Of course, the first answer is going to be this is a duplicate of another one. Alrighty. There's something called finalize, which is called at the discretion of the garbage collector. Alrighty. So no, there's really no destructor in Java, which if you're used to doing C++ may seem odd. The return statement, we know what a return statement does. It returns a value. Where are we using return statements in this block of code? We only use them in a couple of different places, but we did use them. Remind me. Not the rhetorical question. Where are any of our return statements in this block, in this code that we have written so far today?
They'll be in the classes. Yeah.
They're in the coordinate class. We used them in several different places.
The getters,
The getters.
the toString, and the equals.
Exactly.
Anything
Right.
that's not a void type.
Has to be one. Right. Very good. If you're not returning, if it is a void function, you don't have to put the return keyword. If you do, as a matter of fact, NetBeans flags it as a warning, which is kind of silly. I like seeing return statements, but you know. So void is how you declare it if it's not going to return anything, just like our setters. Our setters didn't need to return anything. For methods with a void return type, it's legal to have an empty return statement, which is return followed by a semicolon. However, you don't have to do that. And Java NetBeans will indicate that as being a warning. Return statement within a loop. Software engineering observation. Real-world programmers are often asked to maintain, fix, and improve other people's code. In doing that, they oftentimes find themselves having to examine the loops and the loop termination conditions in the program they're working on. Therefore, it's important that the loop termination conditions are clear. Normally, loop termination conditions appear in standard places, while the loop header, the do loop closing, the for loops heading. What this is telling us is don't go hiding return statements inside the loops unless you really, really, really have a good reason to do so. So what if I was writing some statement here, that was going to ask the user to create some coordinates. So, Boolean keep running is equal to true. And then while keep running, this is going to go nowhere fast, so I wouldn't necessarily type it in. While keep running, we're going to print out, please enter your data, or -1 to exit. And then we check, int data is equal to 0. If data is equal to -1, because our scanner, we used our scanner and we checked it, then break out of the loop, or return, something like that. This may be hidden in a whole bunch of code inside that while statement, because your while loop may have 100 lines of code. And then there's one sneaky way that it could return out of the loop that's not defined here. You want to try to avoid that. I do it all the time with a break statement as a way of validating, if I'm using a sentinel condition. Sentinel condition is a data value, that means terminate this loop. It's not necessarily the best kind of programming, but I find it easy for me to write and understand. I don't know if anybody else maintaining it would find the same way, but I tend to do that. I tend to make it just a while true loop rather than even have any pretense that there's another condition that controls this. And then my break or my return would get out of it if they typed in a -1.
And usually the compiler will warn you if there's potentially no way to escape your loop.
Hopefully. Let's do that. This is now an infinite loop. There's no way to leave it. Ew.
See, whenever you build it, that's whenever I got the warning.
Try this once more with feeling. Clean and build. I'm not getting any warnings.
There you go.
That'd be useful.
Whenever I edited your code,
Yeah.
because whenever I threw it inside of the loops, the break statements were just breaking that loop and not breaking the actual while loop.
Right.
Like that.
Yeah.
So whenever I hit clean and build on mine, it said the actual exiting is inaccessible.
Yeah, I got the same one. So that I created a Boolean like, not done or something.
Okay. Yeah. That's interesting. Next time you see that, send me that file or take a screenshot of it because I want to see how to duplicate that. It certainly will tell you if there is unreachable code. Like that, I have a return statement, but that's not even a warning. It's a flat-out error, unreachable statement. C, again, is loosey-goosey. It'll let you get away with that. It'll generate an error, a warning, but, C generates a lot of warnings, and people don't always go in and clean out all the 4,000 level warnings. So, in the interest of maintainability, you should use restraint when considering hiding a return statement inside of a loop. Now, the one kind of exception to that is, no pun intended, is that once you get into exception handling, it's considered perfectly okay to throw an error inside a loop. In fact, it is a preferred way of dealing with error handling. And a throw statement is essentially a return statement with prejudice. It says, okay, we have failed. But error handling, I guess, is a different thing than that.
Is it okay to have like multiple types of returns, like if this, then return this, else, return something else?
Yeah. You just have to try to make sure it's clear than the next person to come along.
Now, what it was doing was the way you had your program set up, your print line statement of done became unreachable.
Okay.
So it's throwing that error.
Okay, yeah.
Whenever
So argument passing. Although it doesn't always look like it, Java uses pass by value to pass arguments to methods, meaning that you get a copy of the value. You don't get the original thing. So if I write a function like this, I'm going to go back up to my dummy one, and I'm going to make it take a parameter called a. And then I say a is equal to 20. When I call the dummy function from within main, if I say int, I'm even going to give it the same name to make it look as tempting as possible. If I call dummy and I pass in a, and then I print out the value of dummy, what you want may not be what you get. What is it going to print? Is it going to print 20 because after we got done with dummy, a was set to 20, or is it going to print 5?
Should still print 5.
It should still print 5, and the reason for that is that Java, unlike some other languages, does not have a mechanism for pass by reference. Pass by reference is when this variable is actually the same as this pointer, as this variable. It's like passing in by pointer in C++, if you can pass by reference. But Java doesn't do that. So this is just a mere copy of 5. And yeah, we can set it to 20 if we want, but that doesn't matter. You know, this is still the original. It's like we passed in a Xerox copy of that data into this method. You can burn that data if you want to. You still have your original of it. So this would still be 5, even though we tried to change it to 20. Let's prove that. Ew, I still have an error somewhere. Right there, yeah.
Like C, it's just like a little ampersand or something.
Right, there are different ways you can do it. C has your ampersands. C# has a ref keyword. You know, there's lots of languages have the ability to pass by reference. Java does not. But sometimes it looks like it's passing by reference. And that's if you're passing in an object. I'm going to make a dummy2, or no, I'm going to make a method called wipe coordinate that's going to reset all the values of the coordinate. So we're going to pass in a coordinate, and it's going to set x, y, and z, and this is going to be the very last thing we do. C dot set x equal to 0, C dot set y is equal to 0, and C dot set z is equal to 0. Public void, it doesn't need to do anything. Okay. So when I call this one, I just created coordinate 2 and it has these numbers in it, but then I'm going to wipe it out. Wipe coordinate, I'm going to pass C2 in there, and then when it prints it out, it's going to demonstrate that these variables were all reset to 0. Oh, I forgot to make it static. If you're inside a static method, you can only call other static methods in the same class. And the reason for that is you don't have an instance. You don't have a this keyword that you could refer to. Okay, so it passed that wipe coordinate thing. It successfully reset C2 to be 0, 0, 0, even though they were previously 1, 2, 3. And that doesn't sound right, right? Because we just said that we pass in and we get a copy of the data. Well, what is the copy of the data when you're dealing with references instead of primitive values? It's the address of that variable. So here we have an address to that variable, or if you're a C programmer, we have a pointer to that variable. So we can go ahead and change it like that. We can change the members. We can call the members. We can change the instance members of it. However, we cannot change it as a whole. We cannot do this. C is equal to null. That won't do anything. It still successfully works. And the reason for that is we just changed the pointer there. You know, we didn't change the original data. By the time we get out of here, C1 is still equal to C2 still points to the same memory as it did before. I'm not totally sure if that makes sense, but if you're using pass by copy, pass by value, which is what Java gives you, if you try to change primitive parameters like this, it doesn't work. If you try to change reference types, It does work as long as what you're trying to do is not create a new reference. If you wanted to create a new reference, you should return that reference. You know, we could do return C there, and then you would be able to use that. That'd be the only way to get a new reference out of this. All right, guys, we typed a lot. We may as well give ourselves credit for it. Let me real quickly make a Dropbox for this. Do we have any homework that's still upcoming? Because if not, I've let y'all slide by not assigning any. Yeah. Okay, my mistake. I'm going to call this one in-class coordinate because I don't remember which in-class assignment this was. Refresh your Dropbox, you'll see the inbox called in-class coordinate. Submit to there. Our take-home assignment is going to be to make a class that looks like this. Implement a class that's called circle. All it's going to have is a radius. You're going to need to add the getters and the setters for it. So you'll need set radius and get radius. Add a constructor for it so that you can create a new one. Pass in the value of that radius. Add a, let me insert a new line, new page here. Add a equals and a toString method. So write the above class and use it in a client class main, showing that toString and equals works. Real easy one. It's not complicated. We're not checking the volume or the circumference or anything like that. This is just to prove that we know how to program from UMLs. Alright, I'll upload that as well. I'm going to go ahead and make it due next week, but if y'all get stuck on it because we didn't cover it adequately, send me some texts or emails saying, hey, that's not fair, you know, and then we'll extend it.